All right, so this one is number 51 out of chapter 2.3, page 128. This question asked us to find the rational zeros for f of x is equal to 2x to the fourth minus 17x to the third plus 35x squared plus 9x minus 45. So nice big polynomial there. So for this particular one, first off, we can look at the big power and know that we are looking for 4 zeros. Again, they may or may not be rational and they may or may not be real. But that's kind of our guiding principle there, and of course there could be multiplicity of more than one, in which case we'd have the same answer occurring twice. But in this particular problem, we're going to start with the rational zero test. So the rational zero test says that we take the factors of the constant, okay, and the constant in this case is negative 45. So I'm going to take the factors of 45, which are 1, or plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 9, plus or minus 15, and plus or minus 45. I believe I got all of them there. Okay, and we're going to take that and we're going to put it over the factors of the lead coefficient. Okay, and in this case, our lead coefficient is 2, so we only have a couple here. So we have plus or minus 1 and plus or minus 2. So now we need to go through and do every single combination that we have here. So seeing as though we only have 2 denominators, I'm going to go ahead and start with 1 as the denominator. We're going to list every factor that works for that. So here we have plus or minus 1 over 1. So one of the possible factors is going to be plus or minus 1. Then we have 3 over 1, so we have plus or minus 3, and kind of continuing plus or minus 5, plus or minus 9, plus or minus 15, and plus or minus 45. Okay. Then we need to move on and have 2 as our denominator and do every combination including that. I'm going to start right over here for those combinations, in which case we would have plus or minus 1 over 2, plus or minus 3 over 2, plus or minus 5 over 2, plus or minus 9 over 2, and then for the last 2 as well. And plus or minus 45 over 2. Oop, I'm a little off the page there. All right, so obviously in this case we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible factors. In general, we're not going to want to go through, especially in the digital age when we have resources, and go through each and every one of these. So we can use our calculator from here, but it's always a good idea to have a basic idea of what you're looking for. So I went ahead and I already have this entered in my calculator. Wrong page. So I went ahead and put this in here. I hit graph, and the graph will end up looking about like this. Again, we can see here that negative 1 looks like it might be an answer, and that was one of our possible solutions. And then we're out here at about 1.5, which 3 over 2, that looks like a possible solution. And going on, we can see that it looks like we're going to have a few rational zeros. But one of the ways we can check, do a quick check, is to go ahead and check our table, and we see here that we do have one x-intercept at negative 1. So I can write that down. So x-intercepts, or zeros, looks like we have one at negative 1. Y is equal to 0 at negative 1. Y is also equal to 0 when x is 3. And go down and see if we're lucky with some of the other ones. Yep, looks like we have that y is equal to 0 at 5. And then looking back at our graph, we see that we've counted for this one, and this one. So we're looking for one right in between 1 and 2. Now, this is where it gets kind of nice in that if we look for numbers between 1 and 2, there's only one. So I can be pretty confident that my last 0 is going to be 3 over 2. Now, you can verify that using synthetic division. And you will want to verify it. However, at this point, we don't particularly need to. And just because I have gone over that, if you have questions on that, you can go ahead and look at the example number 6 for number 61, or you can look at the example that I did simply labeled Chapter 2.3, Finding Zeros. It'll be the same method. You just use synthetic division to see if you end up with a remainder of 0 with 3 over 2. And you should.